Chapter 12, Objectives. Give the IUPAC and common names for alcohols and phenols. Identify common names for thiols and ethers. Describe the solubility of alcohols and ethers in water. Identify the products of dehydration and oxidation of alcohols. Write the IUPAC and common names for aldehydes and ketones. Draw the condensed structural formulas when given their names. Describe the solubility of aldehydes and ketones in water. Draw the condensed structural formulas for their oxidation and reduction products. Identify chiral and achiral carbon atoms in an organic molecule. So in 12.1, we'll learn a little bit more about alcohols, phenols, thiols, and ethers. An alcohol contains the hydroxyl group, the OH, which replaces a hydrogen atom in a hydrocarbon. So if you look down here at methanol, so here's our methane, which would be CH4, but this says CH3, yes, because it's CH3, and then we have the OH, so it's methanol. Now, a phenol contains a hydroxyl group, the OH, but it's attached to the benzene ring. Notice it's a figure down here. In the names of alcohols, they're going to replace the E with an O. So notice, we just mentioned a bit ago about methane. So if methane with one carbon, four hydrogens, if we have a one carbon alcohol, it's going to take the one hydrogen away and replace it with an OH. So you're going to replace the E of methane with ol, methanol. Now the old common name before the IUPAC naming came along, they called it methyl alcohol. So let's look at ethane, a two-carbon alkane. Now then, if we take one of the hydrogens away and replace it with the OH, the alcohol group, the IUPAC naming has us saying dropping the E of ethane and changing to OL, so ethanol. That's the type of alcohol that is commonly brewed to certain different percentages. So we have our old common name before IUPAC naming came around, which is ethyl alcohol. So guided naming alcohols. You first of all name the longest carbon chain with the OH group. If it's an aromatic alcohol, i.e. has a benzene ring, you name it as a phenol. You number the chain starting at the end closer to the OH. The OH has precedence over the other substituents. That's just the alkyl substituents. Give the location and name of each substituent relative to the OH group. So let's look at it. So we have three different examples, and let's see how we're going to address each of them. So if we just have 1, 2, 3 carbon chain with an OH at the end, or a 4 carbon chain with an OH on a second carbon, or a 6 carbon chain that has an OH on one end and a methyl group on the other, let's see how we're going to address it. First of all, 3 carbons long is going to be propane, drop the E and add OL. 4 carbon chain is butane, drop the E and add ol, so butanol. 6 carbon chain is hexanol. Now we need to say exactly where the OH is located, and we know the OH, we're going to start the numbering at the end of the carbon chain closest to the OH, so we're going to call this 1-propanol because it's on the first carbon. So on this chain here, the OH is closest to this end, so we're going to name it 2-butanol. And on this 6 carbon chain, the OH is on the second from the end, so we're going to call it 2-hexanol. However, on this last one, we now have a substituent that we now need to name where it is, and so the OH takes precedence, so that means we must name from this side that has the OH closest to the end, so we name 1, 2, 3, 4, 5. So 5-methyl 2-hexanol. Now, if the OH on our propanol is on the second carbon, we would name it 2-propanol. And most of you have that in your medicine cabinet at home. However, it's probably not called 2-propanol. It's probably called by the old common name, which is the isopropyl alcohol. Or you may even just call it simply rubbing alcohol, but the 2-propanol. Now, antifreeze is made up of an OH on both carbons, on both carbons, and so the IUPAC name tells us that we're going to have an alcohol on carbon 1 and alcohol on carbon 2, and that we have 2 of those, so that's the diol, 1,2-ethane-diol. However, again, when you're looking at the ingredients on your antifreeze, it'll probably just say ethylene glycol. Or it may be 3-carbon diol meaning 2 alcohol, in which case they are going to be naming it propylene glycol. So you should look at your antifreeze bottle, or now since depending on the time of year, it may be getting warm, and again, it'll still be the bottle of stuff that you put into your radiator. You'll have ethylene glycol and propylene glycol. That will be some of the major ingredients that you're putting in there. Now, glycerol, I don't know if you've ever used glycerol, but it's really smooth is a good word. Now, notice with glycerol, the OL, old common name, the OL ending again refers to the alcohol, even though this is the old common name, glycerol is. But you'll notice here that we have 3 alcohol groups and we have 3 carbons. So we have an alcohol group on each carbon. 1,2,3-propane-triol is the new IUPAC name, not that you need to know that. So let's see if you can name the following compounds. Okay, so the first thing you do is going to do the longest chain on each of these. After you do that, you're going to figure out which end we're going to start our numbering of the alcohol. So on this end, it's a 1. It's on the first carbon, so 1-butanol. Let's see, over here we're going to start from the left and go right, since to put the 2-pentanol. And so then, if we have any substituents on it, then we're going to put the substituents on it. So we have our 1-butanol. Number 2, we have 3-methyl-2-pentanol, and number 3, we have cyclopentanol. Now, phenol, the IUPAC name for benzene with a hydroxyl group is phenol. It is used in antiseptics and disinfectants. One of the issues with it, it is corrosive, but that's also why it's a good antiseptic and disinfectant. So here's some different other examples of other items. You may have heard of poison ivy. Well, that's kind of one of these corrosive molecules here that's a derivative of our phenol group. Now, we also have compounds of phenol that are active ingredients in essential oils of cloves and vinegar and nutmeg and mint. Thiols, you'll notice the OL ending kind of makes you think it's an alcohol, but you'll notice it's a different word, thiol. This is from an old Latin word using sulfur, and thiol contains sulfur. So if you'll look at the periodic table, sulfur is right under the oxygen. So you might think, it has properties that are very, 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 very similar to oxygen because it's in the same family. Well, it has some that are similar, but also because it does not participate in hydrogen bonding, then not all things are exactly like the alcohols. But one thing that's very specific to thiols is that they have strong odors. Think of a skunk, onions, some cheeses. Some cheese might smell good to you, so, it smells good. Now, think of Yellowstone Park. If you've ever gone to Yellowstone Park, if you've ever gone there and you've been near a geyser, it kind of stinks. And you go, what is that smell? Oh, well, that's the sulfur, the hydrogen sulfide that's popping, that's bubbling up. Have you ever wondered why they call it Yellowstone Park? Well, that's because of the sulfur. And guess what color sulfur is? Yes, it's yellow. Now, you'll notice here it says it's used to detect gas leaks. And you go, what do you mean by that? Well, natural gas. If you've ever been around somewhere that had natural gas, you know what natural gas smells like. Well, let's be honest. You don't know what natural gas smells like because natural gas doesn't have an odor. And you go, wait, what is that odor I smell? Well, because natural gas doesn't have an odor, and they know that wouldn't be safe for you if natural gas was just seeping through your house and you didn't smell it, then they put in an odor in the natural gas so that you can smell it. And that odor is a thiol. It says sulfur-containing compound. So the reason why you smell natural gas is you're actually smelling the sulfur from that. Now, in the naming, they are named in the IUPAC system by adding thiol to the alkane name of the longest carbon chain. So let's just look at this. Let's just look at the simple one with methane. Now, if it had been an OH, we would have called it methanol. But because it's an SH, we're going to call it methane thiol. So see if you can write the structure of the following. How did you do? One more functional group that we're going to be talking about in this section is an ether. Now, an ether, you might be thinking looks like an alcohol. No, it has an O that's between two carbon groups. The alcohol has an OH attached to one carbon group. So we need to make sure that we realize that if this O is between two carbon groups, it's an ether, and it totally acts totally different than an alcohol. If you go to name it, the smaller ethers, they name it with the old common names, which is you name one side, you name the other, and then you put the word ether. So methyl propyl ether. Now, ethers had for a long time been used as anesthetics, and a long time they'd used diethyl ether, like when you went to the dentist. They were used for a long time, but it did cause nausea, and they were flammable. So they've developed other anesthetics.